know. Okay. Make sure I record it. Okay, just few minutes. Do that for me. Who get the answer? Let me know so we can get it through done quickly.
Okay. For one, total resistance is 12 ohms.
So
Two volt.
you say number A, right?
Yes, number A.
Perfect.
For number two, answer is B, 20 volts.
Okay, that's number A. On number one. And number B on number two. Okay. Number three.
Uh, 32 watts.
Who else?
16.
What
Perfect.
about
And
Professor?
what?
Is chat an option? I'm putting in my answer there.
Answer will be 16 watt. Okay.
Probably not.
I don't care how can you do.
It's
Like
32 because
32.
you have no, you have 8 volts voltage drop on R3 times. Oh, maybe I'm doing it wrong. Sorry.
Okay. Number four, number five, number six.
B.
B, correct. If you get anyone get a question, you can let me know.
Question 5, answer A.
Perfect.
And that last question is a very good question. It is 0. And you know what's the even better question? What's the
D.
voltage on V0?
You're talking about number 6,
Correct.
A, B, C, D.
C for me.
Which one?
The 0 amperes.
Okay, C.
Yes. And I don't know if you have this question, but I wanted to ask everybody, what's the voltage in V0?
Okay, now I can tell you, very basic, they want VB. You're using the voltage divider, right? VB equal 40 volt times 75. Okay, divide 75 plus 50. That's a voltage divider. Okay, and the question number 6, they want to know the current flow R3. Now, you understand it is open at the V out. Open, that means current cannot flow it. Okay? So that's why there will be 0 ampere. Okay? Next one. Number 1, number 5.
B.
Number 1, A, B, C, D.
I'll
Which one?
say B.
Okay, good. Perfect.
Five is B.
That will be B. And number 5 will be B, right?
Yeah.
Last one.
2.
Which one? Which number? What number? 1 or 5?
5 5 is 2. B.
That's what I saw right here, right?
Yeah, we agree.
Last one.
B.
Number 4 is
Number
B.
4.
Number 4. Number 4.
B.
B.
Number 4 is a C. No.
B.
No. Oh, I said the wrong way. The sum of voltage drop. No.
C.
For 5, it's B.
Number 5.
These are questions from your unit tests, right?
I don't know. Who got the answer for number 5?
C.
You have them in the chat, like 3 or 4 people answered.
C is correct. Okay? I just try to review. Okay. You understand this is a technical program. Okay. That means something is new for students. So that's why you have to get along. Okay?
Professor, can I ask a question?
Go ahead.
Can you go back 2 slides? Or 3,
Go
maybe
back
3.
to what?
Go back to some of your previous questions,
You mean go back to the next one?
to the previous one. The one more. Can you tell us what's the voltage on the outside? VO.
Be out here?
Mm-hmm.
Okay. So basically you understand a open, right? We have not connect anything.
Right,
So you get a current flow R3 will be 0.
right,
So basically V out, okay, it can be same thing with VB.
right. Because there is no voltage drop between 2 of them,
Right.
because there is no current.
Right.
Okay, just wanted to say that for everyone.
Okay. Okay, now, next one. Whoever already done for the DC fundamental circuit board. And Monday coming, you will be working on semiconductor. Okay? That means you have to using the oscilloscope and the generator. Okay, first thing, I want to ask few questions. I'm talking about oscilloscope. Okay? For now, in the class we get two types of oscilloscope. First thing, analog OSC, analog oscilloscope. Second thing, digital OSC. Okay. Let's see. Number one. Can Greece use oscilloscope OSC to measure frequency? Answer.
Yes.
I think yes.
Okay, one student say yes. Who else?
Two students say it.
Say
I'll go with yes.
I say yes.
Yes.
It's no. Oscilloscopes measure time, not frequency.
Mr. Smith correct.
Take
Okay,
it back.
They say yes, teacher.
now just a minute, the answer will be no.
So
Why
what do we need to
no?
measure frequency?
Okay, hold on. Okay, now you understand it. OSC is the time domain. We already talking to you at the beginning. OSC is time domain. Okay, that's the only thing you can see. Time domain, they cannot measure the frequency. Okay, if you want to measure the frequency, you're using the spectrum analyzer, frequency domain. Right now, you already know. If you're not, you're looking into the first handout we display for you at the beginning. Oscilloscope is the time domain. Only measure time. Okay? If you did not agree, let me know. The thing is that is a question they will be asking you when you apply for technician. The thing is they want to know to get a basic understanding or not. Okay? If you disagree, let me know, okay? Now, how can we get the frequency using the oscilloscope?
Is there a formula that uses
Yeah,
time and frequency?
If you want frequency, must using formula. F equal 1 over T. You already know that. And T is a period. That is a very, very basic question. The thing is when you apply for the job, you get into the company. the company, maybe they're not using the scope like we do. Okay? The thing is, the scope still working. Why they have to get a new one? Okay? And now, in the class, we're using a digital scope. Okay? The thing is, you buy the analog scope, that means the old one. Maybe it cost about $200, $300. However, the scope we're using in the lab cost around $800 to $1,000. So digital scope can do more. Why? They just are using the software. When you want to measure the frequency, then they measure the period, then they're using the formula F equal 1 over T to let you know the value of the frequency. Okay? That is a big difference. Okay, now I'm talking about oscilloscope in the class. Okay, that's the TDF 210. And you can see few more, a little different from this one. However, that got more money. So they get more function. Okay, better than this one. This one are basic when we bought at the beginning. Start with the digital oscilloscope. So when you see on the oscilloscope, you can see they divide it in here. 1, 2, 3, 4, 5, 6, 7, 8 division. That's for the amplitude or for the voltage. Okay. And the time will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division vertical for the time. Okay. And you can see this is the channel 1. This is the channel 2. Okay. And the channel 1, you can set how many volts per division. And you can count. Then you can know what the voltage V peak or V peak to peak of the sine wave. Okay. However, you can see here, you get the maximum. For example, you turn around maximum, you can get 10 volts per division. So they can display for you. This is the 8 division. If you time 10, maximum voltage, you can measure 80 volts. Now, if you connect to your outlet, what the voltage on your outlet?
110 in United States.
110.
20.
Okay. Now, okay. Outlet. You can say 110. What volt?
Volt, yeah.
Volt what?
AC.
AC. Okay. Now, you can say VAC. If you don't want using VAC, you can using VRMS. Same thing. Okay. Now,
That's the effective one, right?
okay, we're using either one, VAC or VRMS, mean the same. Okay. However, on the scope they display V peak and V peak to peak. So if you want to get a peak, how can you get V peak?
You multiply it by a square root of 2, from what I remember. So that's 1.41
Equal
times.
0.707
Uh-huh.
times V. Now divide. Sorry, you want V peak, right? So equal V S VAC, sorry, divide 0.707. And if you want V peak to peak equal to time V peak. That's a very basic. You need to know. So if 110 volt AC, okay, then you can get V peak equal.
I'm getting 155.
Okay. Then V peak equal. Okay. VAC divide 155.6. Okay. And if you want the peak to peak, you multiply by 2. Three one point two. Peak to peak. Okay, so any question up to this point? And I can tell you one thing. If you get a 300 volt, you cannot see the signal. The thing is that only go up to 80 volt maximum. If you set it to 10 volt per division, you get 8 division for the voltage bottom to the top. Maximum you can get 80 volt. And now you can get up to 300 volt. You cannot measure. Can you recognize that?
Yes.
Okay.
Yes.
So that's why the scope probe or the oscilloscope, they get set it up to select either by 1 or by 10. What that means for by 10? By 10, that means if you set to the 10 volt per division, and you have to multiply by 10, okay, to make it display the signal. Okay.
So are you saying that there is a button here to multiply by 10 and increase everything 10 times?
Right.
Okay, where is it?
Now, not yet. Try to
Okay.
understand that when we go into the scope, okay, then you can recognize.
Okay.
Okay. Now, if you see the scope in here, okay, you get channel 1, channel 2, and whatever. In here you can see, okay, what they display. However, what I want to tell you, you get 1, 2, 3, 4, okay? That means 4 window, okay? 4 window. And normally, we set first window here for channel 1, second window channel 1, and next for channel 2 and channel 2. We're telling you how can we set it, okay? But the first thing, what you need to do is set second window here from the top to channel 1, next one channel 1, and next one channel 2 and channel 2. That's the first thing you have to set. Second thing, on channel 1, what you want to measure. You see that? You set to measure peak to peak. And the second channel 1, you want to measure frequency. Same thing for channel 2. Okay? And you can see, you can measure the frequency, you can measure the period. Okay? That means more measurement. You can try to set it up. Okay? And also, if you're looking in the bottom here, right now they say channel 1, 50 millivolt per division. Okay? And channel 2, 10 millivolt. Okay? And this is for the time they will be off. We don't care. So basically, when you see that oscilloscope, you're able to recognize, okay, this is what channel 1, channel 2, okay, that's only 2 channels, okay, and either position or whatever here, okay? We don't care when you read it, you're able to recognize, okay? Cursor, measure, display, auto set, okay? Now, we'll try to telling you, okay? How can we set it up? How can we do? Okay? That will be showing you a little more. That's a handout. I already uploaded, okay? Download that. Okay, now you can see. This is the scope probe. Okay, you can see this is the route. This is connect, okay, into your circuit. And they given you another one here, right here. Okay, if you go into the left, they say by 1x. If go to the right, they will be 10x. Okay,
So you are saying if you're using this adapter that's shown here and you use 10x, you could do
turn to the right,
the wall power you could measure.
right.
Or okay.
That means if the signal is too big, scope cannot display, then you have to set into 10x. Normally 1x. That means exactly whatever you see. Okay? If you get a question, anything, you have to stop me.
Okay.
Now, this is the thing you need to bring it out. Okay? Minimum setup must be done using oscilloscope TDS to 10. Pay attention on 5 window and 5 button from bottom up. First thing, you want to set each window to design channel. Like I already telling you, okay? First 2 window to channel 1 and the next will be channel 2. They telling you, press button, auto set, then measure. That means they're telling you, first thing you have to press auto set, okay, then measure. Okay. Number 2, press the top button, 5 from bottom. Then select the source. That means they're telling you press this one. Okay, the first one. Try to select the source in here. Okay, whatever. Okay. Okay. Number 1.3. Press each button to change the window to design channel 1 or 2. That means on the next 2 windows, you press channel 1. And another one, you press channel 2. Okay? Now, next one is try to set each window to design measure. What you want to measure? Okay? First thing, you have to press the same thing. Auto set, measure. Okay. And from the top button, you select type. Okay. Press X button to select the following measure. That means you go into channel 1, you want to measure the peak to peak, or IMF, or frequency period. And you're doing the same thing for channel 1, a second window. And you're doing the same thing for channel 2. Okay? When you're reading the instruction telling you what to do, if you're confusing something, let me know. Okay, we're already telling you. You set each window for what channel you're using, channel 1 or channel 2. The second, you set channel 1 or channel 2 to what you want to measure. Okay, if you go to number 2, okay, then you get up to that point. Okay, now, number 3, set scope probe matching. What that means? If your scope probe using you set by 1, then on the oscilloscope have to by 1. If you set by 10, and you have to set by 10. In here, they're telling you, first thing, 3.1, press channel 1 menu or channel 2 menu. I'm showing you here. Channel 1 menu right here. Channel 2 menu right here. Press on that. Okay. Press channel 1 menu or channel 2. On the probe window, press the button to change 1x or 10x. The probe connected to input channel 1 or 2 must be the same. Okay? That means the scope probe, okay, have to be the same. Number 4, set AC or DC coupling. Okay. If you want to measure the DC, then you set it to DC. Okay. Otherwise, you wanted AC, V peak to peak, VIMS or VIMS or VAC. Now, how can we set that? Press channel 1 menu and channel 2 menu. On the coupling window, press the button to change to AC or DC. Okay. And here, they say DC will display both AC and DC. AC only display AC. Okay. On the oscilloscope, when you set it to DC, they will be display both signals, DC and AC. However, if you set it to AC, they display only AC signal. Okay, any question up to this point? Okay, we keep moving. To get the measurement, press auto set, then measure. You can read the value. Okay. And also they say press auto set and measure button each time some input changing. When you change the input, that means they will be changing. Okay. Next will be using cursor to take the measure. You follow the instruction. First thing you press the cursor button. On top window, press button, select voltage or time to measure. On the source window, you select channel 1 or channel 2 and also the map, either one. For voltage measure, using position button to move the cursor 1 and 2 and read the measurement data from data window. For the time measurement, select time in step 6.2. Okay, that means on 6.2 here, okay, you select voltage, now you want the time, then you select the time. Okay. On the scope, on the source voltage, select channel 1, 2 or map. Using position button to move the cursor 1 and 2. Then you can read the measurement data from window. Okay. Using the oscilloscope to measure the unrounded voltage. Okay. Now, you can see this circuit. Okay. I want to measure let's say use DMN measure dB. Okay, so now you get a DMN high. Connect to what? To point B, correct?
Right.
DMM low. Okay. Connect to where?
To the ground.
Perfect. To the round. They're telling you one thing. If you want to measure using the DMM, they given you only single point. Okay? Then the other side of the DMM must be connected to common to the route. Okay? So now we want to measure V R1 Now, basically, VR1, that means the voltage across R1. Okay? So, that will be telling you, okay?
Your assistant covered this on whiteboard 2 days ago in very detail.
Okay, we get a point A here, okay? B here. So, basically, if you remember, VR1 equal the voltage from VA to B, VAB. And that will be VA minus VB. That's the basic. Okay? So, I want to know, how do we measure VR1?
So what you're doing, you care about the difference between the two, right?
You're using the DMM,
Right. So
telling me the high side DMM connect to where?
the red goes to A, black to B.
Connect to pin A. And DMM low, connect to B. You're very good, man.
I was in class on Tuesday.
That is what I want to emphasize.
So to measure.
Okay? That is a very, very important to you. Okay? When we want to measure a single point, then the low side of the meter have to be connected to the ground. If we want to measure the voltage from one point to the other, then you have to apply, for example, VAB. That means voltage from A to B. VAB equals VA minus VB.
Right. So you are not measuring voltage compared to the ground, but compared to a different point in the circuit. So that's why your black
Exactly.
lead moves.
Exactly. Now, in here, they're telling you, using scope to measure unrounded. You see that? Voltage. That's
Yes.
VAB. I just talked to you.
Thank you.
For example, you want to measure VAB equal VA minus VB, no round. They're telling you, connect the scope probe channel 1 to A and probe channel 2 to B. Okay? And you press auto set measure. Okay? Manual set voltage both channel have to be the same. Then you press the cursor button. Then select a voltage in height window and select a math in the switch window using the cursor to measure and get the value from delta window. Okay? That means you're still following instruction exercise more and more time. Okay? Then you're able to get along with the oscilloscope. We still get more, but I not go to that for now. We don't have enough time. Now I'm talking about the other generator.
Okay.
Okay? This is a generator ISR. We get a different type of generator, but the function will be the same. Okay? This is the output will be connected to the circuit. Okay? Output. So, function to select signal. So, this is the function here. What signal you want? You want sine wave, square wave, or something else. Normally, you will be using sine wave. Set it to sine wave. Okay? For the frequency, right here, the range, 10, 100 hertz, 1 kilohertz, 10 kilohertz, and so on. So if you need 1 kilohertz, you can set it to 1 kilohertz. If you get 200 and let's see, 200, you get 5 kilohertz. You cannot keep 1 kilo. If you set 1K, that means frequency go from 0 to 1K. Now you want 5K, you must be set to 10K. Have to be higher. Okay? Turn the knot amplitude to get the voltage. You see, amplitude right here. You turn around. Okay? They display on the oscilloscope and you're able to get the voltage you want. 10 volt peak to peak, okay, or 5 volt peak to peak, and so on. Turn the notch frequency to get desired frequency. If you want 5 kilohertz, you have to put the range to the 10 kilo. And you can see they will be displayed. You change the knot, okay? They will be go to 5K. Next, connect BNC cable, generator cable, to generator output here. Okay, let's see. I try to see we can get the cable. Okay. That is the cable for generator. Okay. This side connect to the generator output, and the red one, that's the high side, and the black one, the low side. Okay. That means you connect into the output here. Okay. And connect to your circuit. Okay, any question on the generator? This is a frequency, you can change it. Okay. This one you not use it. Okay. Now, only I think I can let you guys know the maximum voltage on the output here, I think about maybe go to 30 volt peak to peak. However, the minimum coming out, I think maybe a 1 volt. Okay. That means you want the signal smaller than 1 volt. You cannot do it. Okay. So that is, I can tell you quickly. You can using the offset here. They say pull, okay, pull it out. Okay, that will be telling you. You can adjust the signal, go to smaller. You can go to, they can go down up to 300 millivolt peak to peak. Okay, that's what you need about generator. Very simple. Okay, when you try to exercise, more you're working on, will be no problem. Now, on the Monday, okay, I will upload and for each computer in the level. This my program. They will be say OSCTD. Okay, help. If you double click on that one, see that they will be telling you if you want to set each window to design channel, you press number 1. Okay, they tell you press auto set, then measure. Press the top button, then select the source. Press the window to design channel. That means telling you whatever you need. Okay. For example, I want to set to the coupling ACDC number 3. You enter number 3. They say, okay, press channel 1 menu or 2 menu. Press the button to change on coupling window. Okay, that means this program will be helping to you. Okay, do whatever we need. Like you set the probe number 2. Press channel 1 menu or channel 2 menu. Press the button to change on the probe window. Okay, so they will be help a lot. Every time you confuse, you can
Professor, this is the same stuff you were showing us in slides before, but just helping us how to do one specific thing, right?
right.
Okay.
That means you want to set each window, channel 1, channel 1, channel 2, channel 2, for example. then you can enter number one. They telling you press auto set, then measure. Press top button, then select the source. And now you can change each window what channel you want. Okay? So that is the program. On the Monday, I will install in every left phone computer. Okay? You double click on that, and they can tell you what to do. Whatever you want. This is the program here. EXE. Okay? We're using the software to write the program. So you double click on that. Okay? They will be telling you, helping you more to do. They will be good. And later on, you don't have to. Okay? Remember, after for a while, you get a log. Okay, now. Okay, now we're talking about diode. Rectification. Again, okay, we already showed you. This is a sideways, right? That's a positive alteration and negative, okay? So basically from 0 up to the top, we pick from the top to the bottom, we pick to pick. This is a complete cycle, one cycle, period, okay? And this will be a time domain, okay? And this is a display domain. We don't care for now, okay? However, that will be happening for you, okay? What that means for cycle, okay? This is a definition you try to go over, okay? Complete occurrence of the repeating wave periodic signal. So that's one positive and one negative. What is frequency? Number of cycles of a signal occur in one second. Period and wavelength. That's what you need to read. Okay, so you can see this is a sine wave. Okay, and you can see V peak to peak 3 volt. That means from 0 here to here, 1, 2, 3 division. Okay, and they said 1 volt per division. So that's why V peak is 3 volt. And peak to peak 1, 2, 3, 4, 5, 6, you get 6 volt. Okay, and VIMS we already calculate. We average in display 1 millisecond per division. Okay, period T will be 7. Okay, frequency F equal to 1 over T. And they're telling you what the frequency that they using the analog scope. On the scope we're using in the class, you don't have to do calculation. You want a period, you set your scope measure period, they telling you. You want the frequency, then you can telling scope to display frequency. Okay? Now, 14. This is a P.N. Jensen. That means this is a P-type, this is a N-type. Like a silicon. One side they contain positive, the whole, and another side negative electron. Okay? When the electron moving from N to P, that means you get the current. Okay? This is a basically physical semiconductor diode. And this is a symbol. Okay? This is a symbol for the diode. One side anode A. Another side cathode C. Okay? So the diode voltage VD equal VA minus VC. Okay. What they're telling you, diode normally permit electron current flowing only one direction. Okay. They're telling you the current electron can moving from a negative to the positive. Okay? And we're talking about conventional current going from positive to negative. So the diode here only allow current flowing from A to C. Okay? That is the basic definition. Okay, now, first ideal approximation. Ideal permit current flow anode to cathode. That means for the ideal diode, you don't have any voltage for VD. VD equal 0. So the current flowing from A to C. Okay? And you can see if the current flowing from A to C, that means You see, they look like they get a switch inside. They connect it. They go a forward bias. However, if they not connect, look like inside, they open. No current flow. That's what reverse bias. So basically, you try to get with forward bias. What that means? That means they allow current flowing from anode to cathode. Okay? And reverse bias. That means diode will be off. No current can be flowing from A to C. Only thing they show you in here, the difference will be VD ideal, okay, equal 0. But basically they're not 0. You cannot get 0, okay? We're telling you. Reverse bias, diode off. Look like you get an open circuitry. No current flowing from A to C. And the resistance between A and C will be infinity ohm. That means very big resistance. So that's why current cannot flow. Okay, ideal. Diode, remember, VD equals 0 and never happen. Okay, now we're talking about really diode. For second approximation, simple the same thing. However, when the diode on or diode off, you can see you can get the diode for silicon diode will be 0.7 volt. Okay, that only telling you one thing. You see VD, VA minus VC. For silicon diode. Okay? The thing that they're using a diode made by a silicon. So 0.7. Later on, you can see they make by germanium and the VD equal 0.7. Okay? So when you're using the diode, if they turn on, that means you can get a VD equal 0.7. Now, see that one. You get 10 volt here. One kilo ohm, and you get a diode. Okay, now, when you're working with a diode, if you don't know the diode on or diode off, you cannot solve the question. Cannot do it. Need. Okay. To know. Diode on. Oh, if you cannot say it on or off, you cannot solve any question.
But you can also presume something and then see if you are right or wrong. So
If
what
you're looking on this circuitry,
right.
can you tell me the diode here on or off? How do we know they on? Or how
I'll
do
tell
we
you.
know they off?
So you have on the left side 10 volt, and there is a resistor, and then there is a diode, and then there is ground. So for sure, I am higher on the anode side. So I'm gonna have that, if I presume there is no current through R, there'll be 10 volts on the anode. So that means it's gonna be on no matter what in this circuit.
Well, you remember, we're using diode 0.7.
Right, for this circuit, it's gonna be on, that's obvious.
Okay. Again, you have to know. Diode on or off. Okay. I'm telling you the way. First thing, what you need to do, you assign no diode here. What VL equal?
So that's our question from before, okay, right?
Right.
In that case, we don't have current through RL, right? So that means V out is gonna be equal to the source voltage, which is 10
Perfect.
volts.
You see that? First thing, you have to suppose if not wanted at that point, then what the VL equal? And now you say VL equal 10 volt. Okay? The thing is, no diode. That means the open. Okay? Open in here. So VL and 10 volt will be the same. And 10 volt higher than 0.7 volt. So the diode will be on. Okay? So you can say diode on. Okay? From here to here. When you say the diode on, if you leave a diode on the circuitry, you cannot do calculation. You must be substitute diode by the battery, and the value will be 0.7. Okay, so now if the diode on, you can say they will be look like plus minus 0.7 volt. Okay, so forget the diode. When you say the diode on, you must be substitute diode by battery 0.7 volt for silicon diode. Okay, see what they say here. Calculate given VD. Okay, 0.7. Number one, diode on or off. Diode will be on. Okay, diode on. Next day one, what V out? Who can tell me what V out?
V out is defined by the diode, or like you said, you can substitute it with a source of 0.7 volts, so it's fixed at that value. It
So,
is pegged at 0.7 volts as long as this diode is running.
so you say,
I'm saying
Yeah,
my
of course.
answer is 0.7 volts there.
okay, he said equal 0.7 volt. That means this voltage right here. Okay, now I telling you. If you want to using a DMM, a meter connect to measure the your car power supply, battery. Okay, what voltage you get? Normally, car battery will be around
It's
12
gonna
volts,
be
right?
12.6 volts for the car battery.
For the car,
Yeah,
normally 12 volt, right?
correct.
Okay.
First approximation. 12
Yeah,
volts.
that's just a general.
Yeah.
No big deal. I just try to telling you one thing. When you measure, okay, the battery, you get that voltage. Even the car battery supply inside your car, right? They don't care.
So give
However,
us, right,
you
sorry.
measure across battery, you get that voltage. Same thing. When we say you want measure V out, that means the meter will be connect high to here, low to ground. You have to get 0.7. Just a battery. Okay? V out will be equal 0.7 volt. Okay? How to get the current? Current I.
Easiest to do with the help of RL right there.
The difference between
Right.
10 volt minus 0.
Because like your picture says that our limit is actually, that is what is limiting the current, right?
What?
That resistor is defining how much current we have right there.
Yeah, they want to measure the current flowing here.
Right.
Okay? You see, this side you get 0.7 volt. This side you get 10 volt. Okay? You take the different voltage divide to resistor. You get current I. Okay? Now, next, what the voltage across a resistor? V, okay, R equal I time R. Okay? You already get I. That's how we solving for this problem. Okay, quickly answer for this one. Number 2. First
This one is upside down, so we have a lower potential on the anode side, so this diode doesn't have a chance to run like this. Cannot run.
Okay, for the example number 2. Number 1, telling me diode on or diode off.
Diode off.
Off.
Okay, I telling you again. To solve the problem with the diode, and you have to know if they on or they not on. First thing, you have to suppose no diode here. Okay. So basically, you get how many volt here? V out. 5 volt, right?
Right.
So the voltage for the diode, VD,
VD is gonna be minus
This is
negative.
0.
Right.
Minus 5. And given you minus 5 volt. Okay, minus 5 volt cannot greater than 0.7. So answer will be diode off. Okay? Diode only on if VD have to be greater than 0.7 volt. And
Right.
the answer for V out, what V out equal?
The out is just gonna stay
5
at
volts.
5 volts. Yes, correct.
They will be 0.5 volt, they will be 5 volt. What current I?
It is 0.
The thing is the diode open, so no current can be flowing. V across R.
There is no voltage drop on R because there is no current.
What V equal?
0 volt.
0.
Perfect. Okay, so that will be telling you, okay, I will be stopped next meeting. Okay, we will be keep continue to get through for the diode. Anything related, you get a handout. If you get a time, try to read it, okay, before the meeting. So that can help you easy to understand it. Okay. I said this is a technical program. Okay. And that is, you don't have to read too many textbooks. I already go through that. Collect anything we need for technician or engineering. Need to know. My level teaching will be basic technician. However, that's for knowledge for the engineering. Okay. Something apply for technician we emphasize. For engineering, we just pass through it depending on who want to moving on higher. You can go reading better. Okay. And also, you have to be in the Zoom. Okay. And in order to understand, okay, doing your homework, okay, and any quiz if we get, and try a maximum working on the level. No school able to support like we do without no cost for your guy. You don't have to pay anything. Okay? Sometimes you find some private school, you have to pay a lot. Before they get in San Diego, they get one technician class same like we do. They teaching for, I think 1 year cost 20,000. But they cannot get equipment like we do. They just doing like a city college. More theory. Okay? Not like this program. We really get a very, very good exercise. And I just mentioned to you, okay, you cannot moving the ball out of the system. Anything, you have to let the instructor to helping you. The thing is, anything wrong with the system left volt, they got at least minimum 5,000. And each circuitry got a 1,500 to 2,000. Okay, so if you try to make it something wrong, okay, for circuit board or the system left volt, then we have you fix. And now nobody do it. Before, around 6 or 7 years ago, normally I working in the class 10 hours a day. At that time, I still okay, normal. Now I get older, okay, a little change. And the other instructor, they get paid for only 14 hours a week. They cannot spend too much time to fix. Okay. And also I telling you before I get a one technician, okay, assistant. He working full time. I hiring him. He working full time 40 hours a week. He get paid more than we do. So that's why anything I need, I just telling him, okay, fix that one, fix the other one, whatever. However, around 6 years ago, they moved him to somewhere else. Reason may be the budget. However, I get older, so I don't care. I still like to do, I still like to help the people in San Diego can get a better job. So that's why I still doing it. Even I'm work really, really hard. Okay. Not for your tech one. Also, I get a tech two too. Okay. Any questions before we stop it? If you don't know how to do what to do, keep asking. We have, okay.
Yeah, can you tell your colleagues that we have done the training for the oscilloscope so they can let us use the diode board? So that was the goal.
Yeah, whoever done for DC.
Yeah.
And then you coming in, you can talk to lab instructor. You say, okay, I like to working on semiconductor. That means the diode
Okay,
board. And he will change the board for you.
understood. Thank you.
Okay. What I'm telling you one thing, everything you're doing on the left phone, they record it into the server. I'm looking in there, I know whatever you already done. Okay.
Yeah, they printed a report for us. We could see that, the proof.
Someone asking me, take how long to complete this program? I said, normally 1 year. However, they can be a 2 year or 3 year or 5 year or more, depending on what you do. If you not try to do the homework, you not try to do the lab or the test, how can I give a certificate for you? I can allow you can still in the program, but that doesn't matter to me. Okay? So don't worry about you can get a certificate or not. That depends on how you do it in the program. Okay? Any question? Anything?
I have a question.
Go ahead.
So in order to finish take 1 and take 2, we really have to submit all the assignments and do all the levels.
Not being all. Okay, normally you get a 70% up. You cannot get everything, right? So that means depending on how far you're doing, how much you're doing, you don't have to be 100%.
Oh, okay. Sounds good.
Yeah, that's normal, people. Different.
So if we pass after the 6 months, do we get a certificate, or do we have to do Tech 2 to get the certificate?
Okay, the first semester you're right now, that means after this semester, this semester you can get a small certificate for Tech 1.
Oh, okay.
And after you're done for Tech 2, now you can get a big one, that's a completion certificate with a seal. That's
The official.
using for apply the job. The thing is when you apply the job, you can lead you study in this program, okay? And you can copy your certificate for them. And normally the company call me, contact me, okay? You're telling about the student. I can say, okay, this is a very good student. I believe, he know what to do. That's a normal happen. You again, what I telling you, I ran this program for the year. Okay, that means I'm running the program with the assistant, another 3 more engineers. So a lot of students in this program working in San Diego. Okay. Okay, anything else? Sometimes, we stop the meeting. The thing I said, this too many. Okay, for your guy. You need the time to review it, to go over. Okay? To me, no big deal. I can talk anything, or you can ask me in the class. Okay? I still memorize. So my brain's still working okay. No problem. Okay? Any question? If not,
Thank you.
okay.
Thank you, Mr. Thumb.
Yeah,
I have another question.
Thank you, sir.
Thank you, sir.
okay. Question, what?
So are you connected with people that they can help us to join the job that we're doing right now, like the electronics? Like, do you have people that are connected that we can apply?
You mean connect to who?
Like, for example, like a job that they're hiring for engineer. Like, do you help us to get a job?
That after you completion.
Oh, I see.
Then I can tell you how many company in San Diego.
Yeah, that's what I was referring.
If they open, the thing I get a student, my student still connect to me. So I know who working on what company. Like my company, BAE System, okay, or a different company, most of defense company. I get my student work inside. I can ask him, is it, they need a technician, then I hope I can help let the guy know. That's it.
Instructor,
Yeah,
for tomorrow's Zoom, it's just for Tech 2, correct?
yeah.
No Tech 1.
You can come if you want. I don't care.
For the Zoom tomorrow?
Yeah, tomorrow, 5 o'clock, same thing, like your guy.
But I don't need to, correct? It's up to us.
No, you don't have to do anything. Just
All
for,
right. I'll
just for,
probably be there so I can learn a little bit more.
yeah,
All
just
right.
for
So,
your knowledge. That's it, nothing else.
yeah, that's what I was thinking.
So that's why you cannot register for Tech 2. Why? The thing is, in order to get the Take 2, you get a certificate for take 1.
Yeah, after the 6 months, if we pass with a good grade, we get the small certificate.
That means take 1 certificate after the semester.
Okay.
And now then you can go into the take 2. That will be make you more easier. But
Tech 2?
yeah, if you understand now how to do, what to do, save your
Right.
time.
Be more easier, more understandable.
Yeah.
All right.
Okay.
Thank you.
Good night, everyone.
Good night.
Good night, sir.
Good night, teacher. Thank
Good night,
you.
thank
Good
you.
night.
Sir.
Bye-bye. Okay.
Bye bye.
Bye-bye.